In this lesson, we will learn how to graph linear equations, system of equations, and inequalities. Each ordered pair represents a point on a plane. Consider the equation x plus 3y equals 6. The three ordered pairs shown here satisfy this equation. Note that when plotted on the Cartesian plane, the points appear to lie on a path or a line. Connecting the points, we see that all the points lie on a straight line. This is a graph of the equation x plus 3y equals 6. It is in the form ax plus by equals c, where a, b, and c represent real numbers. Since the graph is a straight line, we refer to the equation as a linear equation. Always use a minimum of 3 points when graphing a linear equation. Find three ordered pairs for the equation x plus y equals 3, letting x equal 1, 2, and 3, respectively, yields that y values 2, 1, 0. Note the resulting ordered pairs, 1, 2, 2, 1, and 3, 0. These are three ordered pairs that are solutions to the given equation x plus y equals 3. Plot the points and draw the line that contains them. When we graph a linear equation, it is convenient to find the points where the graph crosses the x-axis and the y-axis. A line crosses the x-axis when y equals 0. A line crosses the y-axis when x equals 0. The point where the line crosses the x-axis is called the x-intercept, and the point where the line crosses the y-axis is called the y-intercept. To find the x-intercept of the line, set y equal to 0 and solve for x. To find the y-intercept of the line, set x equal to 0 and solve for y. Write the solutions for the intercepts as ordered pairs. For the equation x plus y equals 3, the intercepts are 3, 0 and 0, 3. Sometimes it is useful to examine more than one graph on the same set of axes. Having both graphs displayed together makes it easier to compare the data. When there are two or more equations displayed on a graph, it is referred to as a system of linear equations, or a system of simultaneous equations. To solve a system of equations by graphing, we graph each equation on the same set of axes. After graphing both equations on the same axes, we can read the coordinates of the point of intersection from the graph. If the graph of two equations intersects at a point, then the equations are said to be consistent. The coordinate of this point represents the solution for the given system. This coordinate must satisfy both equations. As we can see here, we have two equations that intersect at the coordinate point 2, 0. The solution to the system of equations negative 2x plus y equals negative 4 and x plus y equals 2 is the ordered pair 2, 0. There are three types of systems of linear equations. We saw in the last example that the system of equations had one solution. It is possible for a system of equations to have no solutions or infinitely many solutions. Inconsistent systems have no common solutions, which implies that the two equations do not intersect, so the lines are parallel. Consistent systems can be classified as independent or dependent. Independent systems have one common solution, which implies that the two equations intersect at exactly one point. Dependent systems have an infinite number of common solutions, which implies that the graph of the equations coincide. When the equation x plus y equals 2 is graphed on the Cartesian plane, we know how to find the solutions to the given equation. But what about the points that are not on the line, such as 0, 0 and 2, 1? Because they are not on the line, they are not solutions of the equation. If we substitute the ordered pairs that are not on the line into the equation, we can see that it gives a false statement of equality. If we state that 0 is less than 2 and 3 is greater than 2, we have true statements. The point 0, 0 is a solution to the inequality x plus y is less than 2, and the point 2, 1 is a solution to the inequality x plus y is greater than 2. The equation x plus y equals 2 separates the Cartesian plane into 3 sets. One of these sets is the graph x plus y equals 2. Because this graph is a line, we call it the line x plus y equals 2. The other 2 sets are the half planes that lie above and below this line. One of these half planes contains the point 0, 0, and the other contains the point 2, 1. The half plane x plus y greater than 2 lies above the line x plus y equals 2, and the half plane x plus y less than 2 lies below the line x plus y equals 2. Graph the inequality x plus 2y less than 2 and locate the boundary of this half plane. Graph the line x plus 2y less than 2 with a dashed line because the points on the line do not satisfy the inequality. To determine which half plane is the correct half plane, test 2 points, one above the line and one below the line, to determine which one satisfies the given inequality x plus 2y less than 2. Choose the points 0, 0 and 2, 1. We substituted the values into the inequality to find the true statement. The point 0, 0 does satisfy the inequality, so we shade the half plane that contains this point. In this case, we shade the half plane below the line x plus 2y less than 2. If we graphed x plus 2y less than or equal to 2, we would have the same graph with one exception. For this graph, sketch the line x plus 2y less than or equal to 2 as a solid line. We do this because x plus 2y less than or equal to 2 means that we want the set of points that satisfy the inequality x plus 2y less than 2 and the equation x plus 2y equals 2. When graphing inequalities in 2 variables, remember to find the boundary of the half plane by graphing the equation derived from the inequality. Next, determine if the boundary is a dashed or solid line. If the given inequality is greater than or less than, then the boundary is a dashed line. If it is greater than or equal to or less than or equal to, then the boundary is a solid line. Determine the correct half plane by testing 2 points, one below the line and one above the line. Finally, indicate the solution by shading the half plane that satisfies the inequality. Here we combine equations and inequalities to get a compound graph. This is a graph that shows a system of inequalities and where they intersect. To obtain the intersection of the inequalities y greater than or equal to x and y less than negative x plus 4, we graph them and shade their half planes. The solution to the intersection of y greater than or equal to x and y less than negative x plus 4 is the region where the 2 half planes intersect. The coordinates of all the points in the intersection, or the purple area, satisfies both.